The stream's running. Hello, I'm TigerHawk3, and let's look at the dis module in Python. That's the disassembler. So we'll start that. We will import dis, and then we will import dat. No, we won't. First thing we're going to do is we're going to create some things to analyze. I'm going to go with the Fibonacci sequence, because that's pretty basic. It's actually the first example that you will see if you go to www.python.org. I'm going to call it Fibonacci iterative. N A equals 0, B equals 1. Want to make it short and tidy. How about for I in range n, AB equals B and A plus B, return B, I believe. Fi, how about 4? And range 5, I don't know. 1, 1, 2, 3, 5, 8, 13, 21, fantastic. That's the Fibonacci sequence. Very good. Now let's make a recursive version. This is so we have something to compare. N A equals, I believe I have to do... Do they have to be both 1? No, I think it's just 0 and 1. Return fr n minus 1 b a plus b if n else b. Great. So that also works. This is a popular interview question, I believe. I mean, recursion in general. What's becoming increasingly common is something called fizzbuzz. If you go through a sequence of numbers, and for each number, if it's divisible by 3, you print fizz. If it's divisible by 5, you print buzz. If it's divisible by both, you print fizzbuzz. Sounds pretty basic, doesn't it? The point of that question is to determine whether the person being interviewed can or cannot program. Like, just basic. If they have no idea what to do, you probably shouldn't hire, right? Okay, now we have two functions that do the same thing, but in different ways. Fantastic. There's a dis.codeInfo function, and this function gives us details about whatever we pass it. The supplied function, generator, method, source code string, or code object. Okay. Note how we get a bunch of stuff with new line characters. We would have to print this because it's just a string. There is a different function that prints this string directly. in the to the supplied handle. fr fine, let's do I could do file equals something, file equals output. If I had a with open results read mode as output, I could pass file equals output, and then it would print to my file. But the default is printing to sys.standardout, which we saw last time. Neat. So the file name is standard in because I just typed it in at the interpreter with the standard console input. It has 3 arguments, 4 locals. The stack size is 4. It's optimized, new locals, no free. I don't know what all of this means. Variable names, N, A and B, and I. Very good. Now how about FR? Can't fit the whole thing in, huh? Almost. Okay, that's the last thing. So the iterative one is here, and the recursive one is here. So we have 3 arguments for each. This one has 4 locals and a stack size of 4. This one has 3 locals and a stack size of 5. They have the same flags. There's a none constant. This has none and also 1 as a constant. Names uses the range object. This has fr because it's recursive and it has a reference to itself in it. Variable names n, a, and b looks good. Great. And now for something different. Dis.dis. This is the disassembler. fi. These are the things it does. And this says pair over here. P-A-I-R. 1 positional, 0 keyword pair. Because they're call function. Yeah, there's no keywords in there. Because I just have a range object and there's 1 positional argument in it. Setup loop. I don't quite know what all this means, but this lets you compare 2 functions. Note how they do different things in different ways. This has a function, an iterator, store, load, add, rotate, etc. These are assembly instructions. While this has a load, pop, jump, if false, that's our if, our ternary statement there. Load global, load, subtract, etc. Binary add. So there's no iterator. We can see over here. It has a call function down here, but not in this one. So they are different. How cool is that? 3 positional. This is the recursive call. Has N, A, and B. Fantastic. Disassemble the top of stack function of a traceback using the last traceback if none was passed. I don't have a traceback. Let's try fi, the letter A. That shouldn't work. Very good. Dist b. Disassemble traceback is what it is. So that was what happened. That's the stack trace for that. I don't understand it. I don't use it very often at all. Just disassemble, disassemble a code object. Do not know what that is or how to create it. Get instructions. This dot get instructions, and this is an iterator. So I'm going to do this. Wow, what a lot of stuff. So there's an instruction object with an op name, the setup loop, and this is fi. So we have the iterator over here. Here's the setup loop, 37 to 40. And here's an opcode with an argument value to 40, etc. And there's all manner of stuff. Setup loop, load global, load fast. Setup loop, load global, load fast. So that's what that is with all the instruction objects. Find line starts. Oh, for code. A code object, which I don't have. I'm going to skip those. Bytecode instructions. Dis.instruction. Oh, it has an opcode, the numeric code for the operation. These are used regularly if you are programming in assembly. It's very annoying. This is why there are high-level languages like Python. Op name, human readable name for operation, because load fast tells you that it's doing some kind of load of a value, perhaps, while 124 doesn't really have. You have to just know that 124 loads something. Arg, numeric argument to operation, if any, to none, etc. Arg repro. The way, oh, it's an human readable description of operation argument. So I have some with a string that's to 40, and another that's range over here. N, one positional, 0 keyword pair, empty string to 39, I, B, A, B, etc. Offset, start index of each operation within bytecode sequence. I don't really care about all this. General instructions, NOP, do nothing code, used as a placeholder by the bytecode optimizer. This is commonly called no operation or no op, NOP. Python has something similar as an actual statement, which is pass. Pop top removes the top of stack item. Rope 2 swaps the two topmost stack items. Let's skip all that, shall we? Unary operators. Binary operations. In-place operations. I really don't care. Miscellaneous opcodes. Delightful. This might be a very fast stream. Opcode collections. These collections are provided for automatic introspection of bytecode instructions. Neat. So here are a bunch of op names, sequence of operation names indexable using the bytecode. Let's look that up, shall we? Wait, using the bytecode or the opcode? Let's see if 120 is a setup loop. It is. So there's that. Opmap. Dictionary mapping operation names to bytecodes. How about setup loop? Is 120. So that's pretty cool. These are a list and a dictionary of mapping the number of the opcode to its name and vice versa. Sequence of all compare operation names. Dis.cmpop. How many are there exactly? What are we looking at? 12. Let's less equal, equal, not equal, greater, greater, equal, in, not in, is not, exception, match, and bad. I'm not familiar with those. Okay. Is that a thing? No? I have no idea. Oh, invalid syntax. I used it in the wrong way, because I have no idea what the right way is. It's a compare operation, but it's invalid syntax. Name bad is not defined. Oh, yeah, no, invalid syntax, because it could be 1A, 2, and doesn't like that same error. So I don't know if that's a thing, or if it's just here and not actually usable as anything. No idea. A sequence of bytecodes that have a constant parameter. That's it. It's a list with one element, okay? These are all the bytecodes that have a constant parameter. Okay. Let's look that up. Dis.opname of 100. That's load const. Okay, load a constant. And that's the bytecode that has a constant parameter, and there aren't any others for now. Great. Dis.hasFree. These are bytecodes that access a free variable. Note that free in this context refers to names in the current scope that are referenced by inner scopes or names in outer scopes that are referenced from the scope. It does not include references to global or built-in scopes. Okay, never mind. Dis.hasName. Bytecodes accessible, or bytecodes that access an attribute by name. Dis.hasJrel. Sequence of bytecodes that have a relative jump target. Let's do actually let's print map no, not that. Dis.opname n for n in dis.hasFree. Okay. These operations access a free variable. That's great. How about hasName? And these access an attribute by name. Fantastic. Let's look at the ones that have a relative jump target. These have a relative jump target. HasJABS, an absolute jump target. Cool. Ones that access a local variable. Load fast, store fast, delete fast. Okay. HasCompare. Compare op. Okay. These are Boolean operations. So, okay then. That's some cool things, I guess. The part of this module that I've seen used the most often, the only thing I've ever seen used, is dis.dis. So you can look at the bytecode instructions for the given function or code. I guess code information is code info and show code or something. Don't really see that used very often. Dis, very popular. Get instructions, that's pretty cool. So yeah. That's pretty much it for this module, I think. There's some other stuff in there that I kind of skipped. A lot of just listings of bytecode operations that I don't care about. And it's just a list. Like unary positive implements TOS equals plus TOS. Great. Oh, the top of the stack. It says the top of the stack equals positive top of the stack. Meaning plus. Plus doesn't really... does it do anything in particular? We can have -3, and we can have positive -3. And -3 positive is -3. -3, double negative, that's just 3. So that's what that is. Unary positive, unary negative, unary not, meaning not something, invert, blah blah blah. Fantastic. So that's the dis module. We had a good look at this. And tomorrow game, maybe more Euro Truck Simulator. I'm driving around in Britain. I'm driving on the left. It's very weird. Already I have slipped up once and was just driving on the right for like 3 or 4 seconds, and I noticed someone passing me on the left, and I'm like, isn't this a no passing zone? What is he doing? I'm like, oh, he's driving on the correct side of the road. And then I kind of moved over there. Oops. So probably that. Not sure, but yeah. Thanks for watching, and I will see you next time. Have a good one.